Medicine and Medical Humanities Speaker Series. My name is Ellen Amster. I'm the Hanna Chair in the History of Medicine, and we organize this series here at McMaster. I want to encourage you to pick up a schedule, which is over by the cookies, for the upcoming talk. The next talk is Dr. Samer Ali, who is the director of the Center for Middle East and North African Studies at University of Michigan, and who is in the Department of Arabic Language and Literatures. And his talk on March 28th is entitled The Pharmacon in Arabic Mythology, Wine, Healing, and the Embodied Human. So I hope you'll join us for that. I would like to thank our co-sponsors for the talk today, the Department of History, the Department of Family Medicine, the Faculty of Engineering, the Bachelor of Health Sciences program, and I'd like to welcome students from BHSC, the Department of Medicine, the Michael DeGroot School of Medicine at the Niagara campus, and greetings to everybody in Niagara, and the Division of Cardiac Surgery in the Department of Surgery. So it's my distinct pleasure to welcome our speaker today, Dr. Shelley McKellar, who is the Hanna Chair in the History of Medicine at Western. Let me tell you a little bit about Dr. McKellar. She teaches the history of medicine, the medical profession, and related historical aspects of doctoring to medical students at the Schulich School of Medicine and Dentistry, and she also teaches in the Faculty of Social Science. She's currently working on 2 book projects, one a history of the dental program at Western, and a new project called Cutting to Cure, which is an object-centered study exploring how instruments and the act of cutting have shaped our approach to disease. Professor McKellar curates the medical artifact collection at Western, which is quite interesting for you students who might be interested in medical objects. About 1,200 objects that range from bloodletting instruments and surgical sets to microscopes and pharmaceuticals. She's written several books. Surgical Limits, The Life of Gordon Murray, published from University of Toronto Press in 2003. Medicine and Technology in Canada, 1900 to 1950, 2008. Edited a book of essays in honor of Michael Bliss, which came out from University of Toronto Press in 2008. But today she's going to be talking to us about her book, Artificial Hearts. If you want to take a look, we have a copy for you to take a quick look. The Allure and Ambivalence of a Controversial Medical Technology, which is hot off the presses from Johns Hopkins University Press in 2018. So she'll be speaking us today about this book, and the title of her talk is Artificial Hearts, a Controversial Medical Technology and Its Sensational Patient Cases from Barney Clark to Dick Cheney. Please join me in welcoming Dr. Shelley McKellar.
Well, thank you for that kind introduction, and thank you very much for the invitation to come back to McMaster and to talk about my new book that just came out. I look around the audience and I see some familiar faces, some good friends, some people from the history department, some people from the School of Medicine, even a few graduate students that I recognize. So thank you very much for coming in and hearing about my work today. So I want to talk to you about artificial hearts, and I'm going to ask the question I know you all want to ask me. Can an artificial heart replace a diseased human heart? Yes, technically, but not perfectly. But maybe that's okay. It's a good enough technology. Maybe a good enough technology is acceptable to us in terms of sustaining a life of someone who is dying of heart failure. Consider these patient cases. So this is Barney Clark. He lived 112 days with an artificial heart, but he never left hospital. And that was in 1982-83. But still, that was pretty impressive, considering this gentleman, Haskell Karp, was the first patient ever implanted with an artificial heart, and he lived only 64 hours with his artificial heart, and that was back in 1969. Here's a Canadian case, Noella LeClaire. She was implanted with an artificial heart in 1986 at the Ottawa Heart Institute, and it kept her alive for 7 days until she underwent a heart transplant surgery. William Schrader lived a remarkable 620 days. So that's more than a year and a half with his artificial heart. That was in 1984-85. And he held the record for being the longest living patient with a permanent artificial heart until quite recently. The record belongs to this individual, Turkish patient Nurella Balik, a former professional soccer player who as of April 2017 had been living more than 4.5 years with his technology. Robert Tools lived 151 days with his artificial heart in 2001. He took day trips out of the hospital, including a trip out for lunch to his favorite restaurant, White Castle, for a hamburger. James Quinn, one of the youngest implant recipients at age 51, he regretted his decision to have an artificial heart. And when he was asked if he would do it again, he said he would not. His recovery was plagued with complications. He said that if he had to do it again, he wouldn't do it. He suffered a fatal stroke caused by the device after living 10 months with the device. Kathleen Shores was dying of heart failure in a hospital ICU in Milwaukee, Wisconsin. An artificial heart saved her life in November of 2012. A year later, she underwent a successful heart transplant operation. Troy Golden in Oklahoma City would also have died if not for the availability of an artificial heart. The device kept him alive for 15 months. He returned home, even resumed preaching in his church. So all of these folks have been implanted with an artificial heart. So their diseased, failing human heart has been removed from their body, and in their place, a mechanical heart, a total artificial heart, took its place. And according to Troy Golden's surgeon, Dr. James Long, he said, quote, "It was almost like performing a resurrection, taking someone who was checking out and giving them life," end quote. And it is this resurrectionist capacity of artificial hearts that's so appealing to dying patients, their families, the media, society in general. And it is true, artificial hearts provided extra months to patients to spend more time with their family, or, for those lucky ones, to receive a donor heart and to undergo a heart transplant operation. I would suggest to you, though, that artificial hearts are seductive devices. We are seduced by the promissory nature of artificial hearts as a curative fix for heart failure. And this fits in very neatly with our society's view of the body as this entity of replaceable parts. We have an artificial kidney machine, we have artificial hips, we have artificial knees, and so on. So wouldn't it be wonderful if we could pluck off the shelf, ready to go, a mechanical heart, an artificial heart that would save the life of a loved one facing heart failure? Artificial hearts are life-sustaining but imperfect devices with a controversial history. And it's this history of artificial hearts that's relevant, I think, for us today, because it speaks to the desirability and sustainability of expensive end-stage disease therapies. So consider, do such devices save lives as a technological fix, or do they only buy time? So they're expensive, makeshift measure prolonging the inevitable. Are the two aims mutually exclusive? Is one intention less valid? Today, artificial hearts are clinical reality in the form of a total artificial heart, or there are partial artificial hearts, or ventricular assist devices, or VADs as we refer to them. So the use of total artificial hearts is not that common, despite the images of the 9 patients I just showed you. The 9 patients who lived with artificial hearts were definitely in the minority of people that receive artificial heart devices. By far, the greater clinical achievement is with partial artificial hearts, or VADs, as life-sustaining devices for heart failure patients. So for patients in heart failure needing mechanical support, more individuals have been and will be in the future implanted with VADs than they will be with total artificial hearts. And to just give you a sense of the numbers here, according to the 2016 Intermax report, over the last 10 years, roughly 90% of all artificial heart implant patients received LVADs, so left ventricular assist devices, in comparison with total artificial hearts. So in the last 10 years, there's been roughly 15,000 implants of LVADs in North America, Canada and the US, compared with about 350 total artificial heart implants. And in a way, these numbers and these device choices make sense. Intuitively, it seemed that to most people, that partial artificial hearts is indeed the way to go. Intuitively, it seems more doable and less drastic to develop a viable device that would assist the diseased heart and thus not require removal of your native heart completely. Consider these cases. This is Esperanza del Valle Vasquez. She has an external VAD. She was implanted with external VAD for 10 days to help recover from a surgery. She had aortic and mitral valve surgery, but her heart wasn't strong enough, and she needed recovery time. She had this external VAD. And that was in 1966. But that same device, in that same year, did not help Marcel de Rudder, who spent most of his time in a coma after he was implanted with that same VAD. So these two cases are both cases of acute needs for mechanical circulatory support. This is Haskell Shanks, who lived 3 months with his VAD, but then died due to infection at the site of the driveline. So this is in 1971, and this is a chronic case in which poor Mr. Shanks had been bedridden for years before he had his implant surgery. So the takeaway here is that whether it's for acute cases or chronic cases, the technology needed to improve. And it did. It did get better. It got much better. This is Peter Houghton. He lived an extraordinary 7.5 years with his implanted pump after his implant surgery in the year 2000. He participated in charity walks and hikes in the Swiss Alps and more. And he died at the age of 69 in 2007. And then, of course, there's Dick Cheney. Dick Cheney, arguably the most well-known LVAD patient, he credited the HeartMate 2 pump with saving his life in 2010. And I'll have more to say about him later in the talk. But I mustn't mislead you. This is a very small patient population that receives an artificial heart, whether a total artificial heart or partial artificial heart, in kind of the millions of people that are suffering with symptomatic heart failure today. In some cases, you can argue these devices have worked well. These devices have extended lives in meaningful ways, but I'm going to argue that this hasn't always been the case. And I argue that there is a patient success spectrum that needs to be foregrounded when we take a look at this device. And think about the meaning of success as I'm giving this talk. Think about the meaning of success in terms of what actually constitutes success from the perspective of the researcher, the clinician, the patient, the family, or perhaps other stakeholders. You could argue that on the one hand, the development of artificial hearts is quite remarkable. And you can be, as I was, quite awestruck by this technology. You can applaud the researchers who developed it. Think about the complexity of this device and what you have to do to make it work in this hostile environment called the body. So this device, if you can build a workable device, this device has to be durable. It has to respond to the demands of the patient. It has to adjust simultaneous to the various needs of the body, whether you're going upstairs, whether you're sleeping or resting. This device needs to move blood at the right speed. So not too fast that it's going to damage the blood, but not too slow that the blood's going to pool and there's going to be clots that are going to be forming. This device needs to be powered reliably. It has to have an energy source that will not overheat, that will not damage the body, or simply not cut out, and then the device fails and the patient dies. So this is an extremely tremendous engineering challenge. Building a workable pump, but also getting that foreign device to work compatibly with the human body. So that's on the one hand. Incredible technology. But on the other hand, you have to wonder, how are these researchers in these early days able to sell this device idea as a doable project? This idea that A, we could build a mechanical pump, and B, we could make it adapt to the human body and work for the patient. You've got to think that this is, on some level, has to be hubris. Who are we to think we can rebuild bodies, and in particular, this very valuable organ called the heart? The complexity of just building this device might sink you, not to mention all the socioeconomic problems associated with complex devices like artificial hearts. Issues such as costs, access, treatment support, patient quality of life, and even the autonomy in terms of the patient's relationship to this device. I think to better understand how and why these devices are in our treatment toolbox today, I think one can look at its history for some answers. A history of more than 6 decades that I think is characterized by a powerful allure, yet almost certain ambivalence regarding its development in clinical use. So you can say allure because this seems like a good thing. This seems a very attractive option to have in our treatment toolbox. But ambivalence, I'm not quite too sure of it, especially when you start hearing about the poor patient outcomes and the poor, horrendous experiences of some of these patients who were some of the early patients of these devices. Driving many of these early researchers in this project, which I should say many of them are clinicians and surgeons, was definitely the clinical need for mechanical circulatory support. Heart disease was and is a leading cause of death. Certainly concerns society throughout the 20th century and well into the 21st century. Heart failure, a chronic disease, is on the rise. Society wants innovative new treatments. We expect treatment options from our medical specialists. We want them to help us when we have these very severe issues with our heart at various levels, stages of the heart disease process. But society vacillates, and we vacillate between hoping artificial hearts, such a complex device, such a radical kind of treatment option, this artificial heart would be a technological fix for us, but we also fear that these devices might make us worse off. It was an experimental technology for many decades. It was and still is a relative last resort treatment option. Here's a chart I put up in terms of the stages, types, and treatments of heart failure. And if you go through it from left to right, you can see where artificial hearts land on this chart. Bottom right-hand corner, right above experimental surgery and drugs and palliative care. Patients in stage D heart failure are in pretty bad shape. And not surprisingly, the impact of mechanical circulatory support varies. Implant patients do not always leave hospital. New health problems arise. Patient quality of life is often questionable. And did I mention the technology is very costly? So in tracing the history of the development and use of artificial hearts, the question of could we do it will really dominate right from the start, late 1950s, early 60s, the question of moving forward with this project, especially as key players start entering the game. This would be quite a remarkable feat to be able to pull off, building a mechanical heart, an answer to the rising problems with heart failure. But remember, this is late 1950s, early 1960s. This is the United States. This is when the government is working on trying to put a man on the moon. There's a great confidence in what will be able to be accomplished. So they have to argue that we can do this, we can build a pump, we can put it in the body, we can help patients. But would such a device actually be viable, and would it actually help the patient? Could we build an artificial heart that would work? I would argue go right to the beginning, go in fact to 3 medical men who are key players in deciding the historical trajectory of this project and what the determinants or criteria would be in denoting success. And those 3 medical men are Dutch-American physician and researcher William Kolff, surgical titan Michael DeBakey, and cardiothoracic surgeon and investigator Adrian Kantowitz. So they're among a handful of researchers who are motivated by the success of the heart-lung machine of the 1950s. So the heart-lung machine came out in the 1950s. It provided mechanical circulatory support for the patient undergoing heart surgery, but it's only a temporary option for a matter of hours only. So many people are thinking, why not build a machine or device that could provide longer-term support, more than a couple hours, possibly days or weeks, even months. And it's these 3 medical men who developed 3 different devices for different patient needs that really start to shape the field. Now, each of them are not naive about the problem. Each of them recognize the tremendous physiological and technological challenges that lay ahead, yet they tackled it anyways. And these are the 3 different devices that they developed. Was one approach better than another? And who would be the first in delivering a viable device? So these 3 devices differ in size, shape, how they worked, and intended clinical use. So let's leave the black box around these devices for now. I won't go into what materials are used or how they work. That's all in the book you can read about. Let's jump right to the end. Let's jump right to the question, did these devices work? So Kolff is interested in building a total artificial heart. A total artificial heart that would take the place of a diseased heart and do all the pumping of blood for that body. So Kolff's total artificial heart worked long enough to keep a dog alive for 90 minutes in 1957. And this was heralded as a huge success. He's the first one to report any kind of success in the literature. It was pretty impressive given what he had attempted to replicate function of the heart. But Kolff never implanted this device in a patient. DeBakey's device is quite a different device. DeBakey's device is an external assist device. So it's attached to the compromised native heart and assists with blood pumping. DeBakey's first patient case came in 1963, and it was not very successful. Patient died. This chases DeBakey back into the lab to improve the device. He makes some improvements. He tries it out in some more patients. Still very poor results. Still not very happy with it until 1966. In 1966, he starts to enjoy some better successes, notably with his patient Esperanza del Valle Vasquez. As I mentioned, she was able to be on the pump for 10 days, of which after that was disconnected, and she made a full recovery and was discharged from hospital. Kantrowitz has developed a booster heart, or U-shaped assist device, which he implanted in several patients also in 1966. His device is smaller than DeBakey's pump. His device has no valves. His was intended for permanent use, not temporary use, and it was placed inside the body rather than an external attachment. Kantrowitz tested his device in 74 dogs over a period of several years before he even considered trying it out on a patient. And in 1966, he implanted it in 2 patients, and both patients died. So, how would you assess these early clinical cases? Was it enough to encourage more research? Would you go forward and implant it in more patients? Interestingly enough, both DeBakey and Kantrowitz declared their patient cases in 1966 as successes. These were patient successes, they argued. And they defined success in a very narrow way that focused on device performance. Yes, some of their patients died, and we never like to have those outcomes, but they would argue those failures helped them to improve the device and to move it forward in its development for future clinical cases. And it's this interpretive flexibility of success that works to retain the promissory nature of these devices. So rather than concede disappointment or disillusionment in this technology, they're going to cling to this idea of success. And we're going to see this over and over again, kind of how they're going to spin it, how they're going to frame it as successful. And I would argue that success was required. Success was required to maintain individual motivation and confidence in this grand pursuit of building artificial hearts. Talk of success was required to maintain the investment, structure, and legitimacy that was being built in this young new research field. Success is a word that is used often and purposefully when describing these early implant cases to both medical and non-medical audiences. And I would argue it sustained momentum and expectations that the realization of artificial hearts would be forthcoming. All 3 of these gentlemen, Kolff, DeBakey, Kantrowitz, they're united in their commitment to both the feasibility and desirability of artificial hearts. Collectively, these multiple approaches help to set out the best biomaterials to use, help decide kind of what's the tolerance of the body for these kind of devices, the mechanics of devices, and so forth. But none of these devices are ready for prime time. None of these devices are ready for widespread clinical use. There's lots of technical problems with all of these devices. Blood clotting in the device, problems with the energy sources, and more. However, collectively, all 3 of these approaches and devices and outlooks of these men work together to emphasize the engineering challenges behind building artificial hearts in this new field of research. And all 3 of them will talk about success. All 3 of them will parade their work out in clinical cases out in front of the media as a way to secure greater research funding. They are confident, they are driven, they want this project to go forward. And they want others also to throw their hat in the ring and to help them develop this field of research. And they do a very good job of lobbying U.S. congressmen and senators to support their research. And it's these two things, both their device research and their lobbying efforts, that contributes to the establishment of and continued support of the U.S. Artificial Heart Program at the National Institutes of Health. And this, the U.S. Artificial Heart Program, is crucial. They provide crucial public funding and a national structure for this undertaking, this grand pursuit of building artificial hearts. This is significant. It gives artificial heart a legitimacy and a national profile. And I would argue DeBakey, as you can see here with President Johnson, DeBakey in particular was quite savvy when it came to Washington and even with journalists. DeBakey is the one that's most successfully in producing this narrative of promise, potential, what if, when he comes to pitch this idea of building artificial hearts. He presents this narrative in both words and with photos, and it's presented all in different magazines at this time that are circulated. It extends in both in medical and non-medical audiences. And the message here is, if only you would allow us to go forward with this project, if only you would support us, give us more time, give us more money, artificial hearts would be forthcoming. And the Artificial Heart Program does exactly that. The Artificial Heart Program antes up the research money, and NIH administrators supported multiple research approaches to develop multiple devices at this time. There would not be one artificial heart, but there would be many artificial hearts to support patients with different cardiac needs. And thus the title of my book, Artificial Hearts, plural. There will be a family of devices, multiple devices, that will be used for different patients who have different clinical needs. From everything to short-term assist devices all the way to a fully, completely replaceable heart. Now there existed a sense of legitimacy, a momentum, you would argue, for this young field of artificial heart research. Kolf, DeBakey, Kantrowitz, they're shaping the field of mechanical circulatory support, and they will for decades to come. Remember I told you about DeBakey's implant and his patient with the external VAD? He was the first surgeon to implant successfully a VAD in a patient, and everyone expected that one of these three gentlemen would also be the first to implant the first total artificial heart. But that was not the case. This feat was attributed to a very ambitious colleague, Denton Cooley, and it provoked tremendous controversy. On April 4th, 1969, Houston cardiac surgeon Denton Cooley operated on the severely damaged heart of 47-year-old Haskell Karp. Karp is an Illinois man suffering end-stage heart failure. So according to Cooley, he says he has never seen a worse-looking heart once he gets in the operating room and opens up Karp. Cooley gets into the operating room and he's attempting a wedge operation, which is extensive restructuring of the ventricle. But he argues that the damage to Karp's heart is just too severe, and after the restructuring procedure, Cooley says that there's just not enough healthy heart muscle left for him to complete the operation successfully. So now Karp's heart is compromised. He certainly is going to die once he's taken off the heart-lung machine. Cooley says, he makes a decision at that point, that he's going to implant a total artificial heart. So he's going to remove what's remaining of Karp's ventricles, and he's going to implant a total artificial heart to keep him alive until a transplant operation could be performed. This had never been done before. No one had implanted a total artificial heart in a patient before. They didn't know if A, this mechanical heart would actually work, and B, if Haskell Karp would be alive within hours, if he would make it off the operating table. Karp did survive the surgery. This is the patient after that device implant surgery. Inside Karp's chest was a two-ventricle, pneumatically driven artificial heart. It was the approximate size of a human heart. But what's most visible, if you can take a look at the picture here, is there's actually 4 long tubes that are connecting the implanted device in Karp's chest to a very large power console that's at the side of the bedside. This power console is roughly the size of a chest freezer, and it contains 2 major subsystems. There's the pneumatic pressure sources, and there's the monitor control unit. And you can see the technician there monitoring it, making sure that the device is working in Karp's chest. No one really knows how long this artificial heart is going to be able to keep Karp alive. So the medical team and Mrs. Karp, they make a nationwide plea for a donor heart. 2 days after the total artificial heart implant, a donor heart is found. A medical team flew Mrs. Barbara Evans, who had suffered irreparable brain brain damage from Lawrence, Massachusetts to Houston, Texas. Think about that. That's over 1,800 miles. That's more than 3 hours on a plane. They fly Mrs. Evans from Massachusetts to Houston, Texas. She arrives at St. Luke's Hospital in Houston. She's pronounced dead, and the heart is removed from transplantation. At this point, Karp has been alive for 64 hours with his artificial heart. He's returned into the operating room. The artificial heart is removed from his body, and Mrs. Evans' heart is now placed in Karp's chest. Karp survives the heart transplant operation, but he's closely monitored afterwards. Now, Cooley and his medical team are very excited to get their hands on that artificial heart device that had kept Karp alive for 64 hours. And they start examining the explanted device to see if they can see any signs of mechanical failure or any other technical problems. And they reported none. They reported no problems with the device. They argued that the interior surface of it and the valves were free of thrombi, so there was no blood clots. There was a smooth lining that consisted of fibrin and platelet deposits, so they suggested that there had been adequate blood flow through the device. Cooley and his team excitedly started talking to journalists, explaining that the device really looked wonderful, boasting that Karp probably could have lived 6 months with the device in his chest. In published case reports in the medical literature, Cooley stated the mechanical heart gave a commendable performance as a simple mechanical pump, and that the total artificial heart had been successful. It had been successful in what it was intended to do. It had worked long enough to bridge the patient to transplant, according to the medical team. But in the end, neither the device nor the heart transplant operation worked well enough to reverse Karp's multiple problems. 32 hours after his transplant operation, Karp died. Now, the media followed Karp's ordeal very closely, and they printed details of Karp's artificial heart operation. They, of course, reported on the grand search for the donor heart. They covered the follow-up transplant surgery, and then, of course, Karp's death. And they are also adding to the spin of the story. They, very loudly and boldly, are praising the artificial heart as this breakthrough technology. This is the promised device, they said. This is going to help extend the lives of many people with heart failure. And, of course, the media frames the event with the typical cast of characters. So there is the heroic surgeon, there's the brave patient, there's the distraught family, and so on. But then the news story turned. The media shifted to the drama unfolding concerning allegations of device theft and lack of authorization to perform this experimental procedure. So Michael DeBakey openly charged Cooley for covertly taking the artificial heart device that had been under development in his lab, DeBakey's lab, and taking it and putting it into Karp without any permission from DeBakey or from anyone on his team. DeBakey says Cooley somehow had gotten into his lab, put it in a briefcase, literally walked out the door, down the street to St. Luke's Hospital, and implanted this very experimental device in Mr. Karp's chest. DeBakey is horrified when he hears about this. He happens to be at an NIH meeting in Washington when he hears about it, horrified about it, because just weeks earlier he had implanted this very experimental device in calves, and the results had been horrible, and DeBakey refused to even consider implanting it in a patient. So there's that part of the story. The other part of the drama is that Cooley's artificial heart operation occurred in relative secrecy, disregarding all institutional guidelines in the use of experimental procedures. Cooley did not gain permission to perform the device implant from the Baylor College of Medicine Committee on Research Involving Human Beings. So this is a group of doctors who could be brought together very quickly to make this emergency decision. Cooley did not ask their permission. So this incident of this covertly taken artificial heart, this incident severed the professional relationship of DeBakey and Cooley. And the accusations and rift between the two surgeons was well publicized. It made the front cover of Life magazine in April 1970. And the feud was legendary. And it became its own story, rivaling the medical feat of cardiac replacement. And the feud lasted 4 decades. Cooley was forced to resign from Baylor College of Medicine over the incident, and the two men refused to even be in the same room at conferences together. And it went on for years, for nearly 40 years. But what about the artificial heart? What's the significance of the Karp case? What kind of impact did it make on the development of artificial hearts? The impact, it had minimal impact. And that's somewhat surprising in my view. Yes, artificial heart technology gained media exposure as a result of the CARP case, although the hype soon led to a crash. CARP had not been saved by the artificial heart. The image of CARP connected to this very large power console was not viewed very well by the public or the medical community. The CARP case did affect expectations, and there was certainly a cooling off of any public pronouncements of success with this device. I think it is surprising, at least to me, that the CARP case did not detonate the artificial heart program. It didn't seem to even discourage a lot of people working in the field. In the end, the medical community more or less dismissed Cooley's implant as a one-off. And this, in fact, is very true. So the Leota Cooley artificial heart was the first total artificial heart implanted in a patient, and it only happened once. No other Leota Cooley heart was ever implanted, and the artificial heart that you see here in this picture that was actually implanted in CARP is now housed at the Smithsonian Institution in Washington, is one of their treasures and one of their more requested objects. But yet, I'd be surprised if anyone in this room knew anything much about this device before my talk today, except maybe Dr. Lee. It is the Utah total artificial heart, also known as the Jarvik 7 heart, that most people remember or think about when I say I'm talking about artificial hearts. It's the Jarvik heart that became one of the best-known medical devices of the 20th century, and that's due to the extensive media coverage of its experimental use during the 1980s and its implantation in hundreds of other patients during this decade. The Utah heart was first implanted in a human in 1982, followed by more implants in about 200 patients throughout the United States, Canada, and Europe, before it was pulled off the market in 1990, and that's when the FDA cited record-keeping and quality control issues with the device, and Symbion, the company, had to pull the device off the market. The Utah heart was developed by Willem Kolff, Robert Jarvik, Don Olson, William DeVries, and others at the University of Utah. And it's the Utah heart, more than any other total artificial heart device, that really raised the profile of artificial hearts as a viable option for individuals with heart failure. It's the Utah heart that extended the lives of near-death patients, Barney Clark, William Schrader, and others by months, resurrecting them in a way that really did astonish their families, many in the medical community, and certainly the public. Many of these implant patients lived, and they woke up, and they told people what it was like to live with a mechanical heart in their chest. Utah researchers loved this success. They declared it a success with their device, but arguably, even they would agree, it was not a flawless device. The overall clinical experiences I'm going to tell you about were a bit unsettling. So Barney Clark here, he lived 112 days with his artificial heart, but as I mentioned, he never left hospital, and he certainly battled complications. When he awoke after his implant surgery, he found himself tethered to a large 216-pound drive unit that was necessary to drive and monitor the heart that was now implanted in his chest. So he's got drive lines now that are penetrating the left side of his body, and these are delivering the pulses of compressed air that are powering the device in his chest. He needs to be connected at all times. Clark's recovery after the operation was very bumpy. No one knew, again, how long this device would work. Everybody wondered, would it alter Clark in various ways? Would it alter his physical being? Would it alter his mental capacity? There was much uncertainty. Clark suffered a series of complications almost from the get-go. It started on post-op day 3. He had ruptured air sacs in his lungs. He had seizures. A valve in the artificial heart itself actually broke, so he had to have that part of the heart replaced. Clark rallied. He appeared to recover by the 4th week after surgery. He stood for the first time. He took his first steps. He even ate some soft food by mouth. Hospital officials released this photo of Clark standing with his physical therapist. And there's another picture they released of Clark on a stationary bicycle. But it didn't last for long. Complications returned to plague Clark. He had reoccurring nosebleeds as well as kidney and respiratory problems. He battled pneumonia, diarrhea, shortness of breath, bloody stool, and fever. His wife that you see in this picture, Una Loy Clark, she told friends and family, quote, "Barney keeps valiantly trying, and we pray we may soon reach the point where things will turn in our favor. but the days are hard. Clark's medical care was complicated, and in the end, the artificial heart was not enough. On March 23, 1983, Clark died as a result of severe colitis and sepsis, which led to multiple organ failure. Clark lived 112 days with his artificial heart. So when Clark dies, the media then starts to create their own narrative, their own story. So the media starts to highlight the courage of this man for being the first patient implanted with a permanent artificial heart. There was no intention ever for him to be transplanted with a human heart. And William DeVries, when he was accused that maybe this wasn't successful, was quite taken back by that. He was quite shocked that people wouldn't see this as a great success story. And William DeVries said this, he said, quote, "To say to only live an additional 112 days is unsuccessful is ridiculous. His case was successful because he was going to die that day. And instead, he saw Christmas and his birthday and his anniversary and even the Brigham Young University of Utah basketball game on television." Yet, there was many in the field that would query the results and the quality of life that Barney Clark lived for those 112 days. Dr. DeVries' most successful case was William Schrader. Schrader was the second recipient of a permanent implant of a total artificial heart, and this is the gentleman that lived for 620 days, and for a period, he even lived outside the hospital in a nearby apartment that was renovated for him. And so for a brief period during Mr. Schrader's experience with the heart, the uncertainty surrounding the device was eclipsed by his story. And Bill Schrader is a wonderful patient. He was very optimistic. He was eager to talk to anyone who would listen, family, nurses, medical staff, the journalists. He was willing to tell them what it felt like to have this device in his chest. He told reporters that he felt super and that with his new heart, "I feel like I've got another 10 years. And reporters asked him directly, he said, "What does it feel like not to have a human heart, but instead to have a mechanical device in your chest?" And this is what Schrader said. He said, quote, "It just sits there. I can feel it. Doesn't bother my sleep. Doesn't bother me at all. I've gotten used to it, and I don't know it's there. Hey, there it goes. It's taken off like a horse now," end quote. So you get a sense of kind of the optimism he has and how he's living with it as part of his body. When asked about the pain and discomfort, Schrader stated that it was comparable to all his previous open heart treatment experiences, his surgeries. These are encouraging early days, lots of photo snaps of Schrader teasing the nurses. There's a well-known picture of him opening up a can of beer and toasting kind of his new heart. All of it seemed extraordinary. DeVries went on to implant 2 more patients with Jarvik hearts, but neither Murray Hayden nor Jack Burcham left hospital after their implant operation. Both battled horrendous complications due to the device. In the end, Bill Schrader also succumbed to death. The device did not keep him alive forever. And what I thought was interesting is, near the end of Schrader's life with the artificial heart, his family requested that no extraordinary measures be taken to address the series of infections, strokes, and other impairments that Mr. Schrader was experiencing. So what I've just told you are some unsettling, I think, outcomes or results from permanently implanting the Jarvik heart. What's not known by a lot of people is that, despite these mixed results, is that the Jarvik heart was used as a temporary device in more than 200 patients for about the next 5 or 6 years throughout the United States, Canada, and the world. So the intention was to use this device as a temporary device, as a bridge to transplant, waiting for a donor heart, and then going forth with the transplant operations. So in many surgeons' mind, they said the problems we saw earlier as a permanent implant, problems of mobility, problems of stroke, the blood clotting issues, we can avert that because we're only looking to use it for a couple days. The problem was, it was not a flawless technology. There were still problems with the technology that were being reported, that patients were suffering blood clotting. They were suffering infections at the drive lines. They were complaining about the mobility issues, and it was an expensive and flawed technology. People started asking, was it doing more harm than good? The media, also part of this story, the media provided a forum for a lot of the political and bioethical debate of the artificial heart, and they start bluntly challenging that earlier enthusiasm around this device as this potential fix for heart failure. So all of a sudden we see this question of, could we do it, become a question of, should we do it? So the media starts to raise a lot of these issues that are being voiced by bioethicists and other non-medical commentators, issues related to patient autonomy, quality of life, cost, and genuine worry that perhaps medical technology has really run amok. They expressed misgivings about the use of an experimental device. They're starting to say that it's more harmful than beneficial. Device inventor Robert Jarvik, he was concerned enough to make this comment to the press. He said that the public criticism was so strong that he wouldn't be surprised if it was enough to kill the entire artificial heart program. In 1988, there was a New York Times editorial that came out, and it called the device, the artificial heart, the Dracula of medical technology. And it went on to say that during its 24-year life, this Dracula of a program sucked $240 million out of the National Heart, Lung, Blood Institute, end quote. So this year, 1988, becomes a very pivotal year. It becomes very clear in 1988 that the artificial heart is in a very precarious position. We've got all kinds of disconcerting outcomes from its recent implants. We have public disillusionment, or at least questions starting to be raised that are being suggested by the media. Symbion Incorporated, which manufactures and distributes the device, they're getting into business problems. The FDA is already making waves about pulling it off of its shelf. So you would think, 1988, this is the moment. This is the moment when the limits of this technology surely will be examined. This is the time when most stakeholders are now going to acknowledge the infeasibility of this particular technology over its desirability. It's at this moment that the contentious debate surrounding the Jarvik heart cases seems to me to be strong enough to break, or at least retract, the momentum behind the development of artificial hearts, but it was not. The program continued on. In fact, what happened is the majority of stakeholders endorsed, rather than challenged, a lot of the scientific enthusiasm to build artificial hearts. The opponents of the artificial heart technology, the critics of this technology, were flabbergasted. Social scientists Renee Fox and Judy Swayze, they expressed their deep concern, how they felt alienated by this move by the medical field to continually moving forward to try to rebuild people. They came out very forcefully against the artificial heart program. They called it hubris-ridden endeavor, that it was a bunch of overzealous researchers, and that it was trying to divert attention and resources away from other basic healthcare needs. In the end, the Jarvik heart cases did not quash the pursuit of artificial hearts from the perspective of artificial heart researchers, even some clinicians, certainly not industry, and even some public officials of this time. Surprisingly enough, the negative reactions that came out leading up to that year, 1988, was simply not enough to turn the tide against the program of building artificial hearts. And I think what happens with this is that it comes back to the context of the times. And maybe we're still in these times. But I think the hopes for a technological fix for end-stage heart disease were very strong. Again, I think it's this resurrectionist capacity of such technologies that appeals to society, most certainly the media. I think it's this spare parts ethos that was part of our culture. I think the bait is the promissory nature of artificial hearts as this life-sustaining treatment. Think about it. This is a medical technology that might alter the usual course of events, that when a person's heart failed, that person died. What if we could alter that course of events? In 2001, Time magazine pronounced the AbioCor artificial heart as one of the best inventions of the year, and they celebrated its success in extending the life of Robert Tools. So remember, Tools, I told you, lived 151 days with his artificial heart, had day trips. There's lots of photo ops of him eating his hamburger at White Castle, but going on fishing trips with his children, and so on and so forth. These seemed to be heady days, 2001. Had a fully implantable total artificial heart finally emerged as this viable clinical option for end-stage heart failure patients? Take a look at this Newsweek cover image. What you see are two open hands. I mean, they're reverently displaying this plastic and titanium device under the headline, "How Technology Will Heal Your Heart." And I think it's these celebratory accounts by the media that really help to sustain all of the public optimism and, I would argue, faith in this technology. But the AbioCor total artificial heart was not the answer. If you know anything about the history of the alveolar toll of your heart, it was approved for a clinical trial of up to 15 patients, but it was only implanted in 14 patients. It was stopped after the 14th patient because there's simply too many incidents being reported of excessive bleeding, device failure, blood clotting, cerebral vascular events, and multi-system organ failure. And it showed that this device needed to be improved. Abiomed, who was developing the alveolar toll of your heart, said, we will take it back to the lab, we will improve it, we'll work on the alveolar toll of your heart version 2, but more or less that technology has been abandoned now. Today, it's the Syncardia total artificial heart that is the only total artificial heart approved by the FDA, Health Canada, and the CE in Europe. It's the Syncardia total artificial heart that, ironically, is an evolution of the Jarvik heart technology that was stripped from the shelves by the FDA that has become the good enough technology. This is what we use today. It's predominantly used as a bridge to transplant device, and it is that Syncardia total artificial heart that actually was used in both the Kathleen Shores and Troy Golden patient cases I talked at the beginning of this talk. So here we have a good enough technology, so it's not a perfect technology, but it's a good enough technology, despite there is still reports of patient strokes and power malfunction. Again, I would argue that the greater achievement lies with the less glamorous sibling of these devices, and that's the partial artificial heart or ventricular assist devices. So remember back to DeBakey's and Kantorwitz's earlier devices. It's this assist device that gets greater clinical and commercial rewards by the end of the 20th century. And it's former U.S. Vice President Dick Cheney who directly benefited from second-generation VAD technology. So in July of 2010, Cheney was implanted with a HeartMate 2 LVAD, and he credited the device with saving his life. So you see here is a photo of Cheney 1 year after that pump implant. He's holding it up in the public eye. He's out actually this year commenting on political events. He's out promoting his memoir, In My Time, at that during that year. But he's also quite willing to share his experience of what it feels like to be living with a VAD. Take a look at his picture. He's noticeably thinner after his surgery. But again, he's praising modern medical technology, what he says for resurrecting him after his latest heart attack. And you can see here, he's always in front of the spotlight, of course. He's on national television. He's waving around his battery pack, showing the interviewer how it is and how it works up, how it's connected to wires, how it goes through his chest. He likes to play with his interviewers. Sometimes he would even disconnect the VAD from his batteries, setting off alarms. And the journalists, people like Wolf Blitzer, very kind of unsettled when he starts doing that, asking him to reconnect it. He repositions the components in his vest, and the interview continues on. This is what Cheney told reporters. He said, "It brought me back from end-stage heart disease. I was in bad shape. Now I'm back to leading a relatively normal life. I fish, hunt a little bit, write books, I'm able to travel." End quote. But if you look more into his experience with his VAD, Cheney's recovery was certainly not event-free. Remember, these pictures are a year plus after his pump implant. In fact, Cheney would certainly have died that day if he was not implanted with a HeartMate 2 VAD. Cheney then spends another 35 days in hospital in the ICU after the pump implant. He has all kinds of problems he's battling. He's battling problems of bleeding, a kidney injury, pneumonia, respiratory failure. He has a pneumothorax, which is an air leak in the lung. Cheney wrote that the LVAD surgery was by far the toughest in comparison to his previous heart procedures. Arguably, you could say, this is a man that should have died that day. Arguably, you could say he has never been so physically weak. So it kind of truths to bear that he should have had a tough recovery. What I found interesting about his experience with it is he complained about the tethering. The device tethering was an issue for him, as arguably it will be for other patients. But Cheney, in particular, said it was very hard for him to be tethered to a battery or some kind of battery pack. He said it required a lot of effort to always adjust to being plugged in to a power source of some sort. In March of 2012, Cheney underwent a successful heart transplant after living 20 months with his HeartMate 2 pump. So political cartoonists, comedians, they're going to have great fun with this, with Cheney's heart operations. And they depict Cheney waking up in his hospital bed as a Democrat after surgeons mistakenly transplanted a bleeding heart. And there's all kinds of comics and comedic routines going on. But jokes aside, Cheney's change of heart really raised the profile of VADs, and I think further endorsed technological fixes for end-stage heart failure patients. Because he's out in front of the media, because he's waving around this battery pack, because he's looking pretty good with it. This near normal life has been returned that he's enjoying at this time. By way of a wrap-up, I hope that you get a sense that the history of artificial hearts was a bumpy one. There was controversy. There was poor patient outcomes. But there's also episodes of promise, of potential, of what if. And of course, I left out big chunks of the story. I didn't tell you about how artificial hearts and heart transplantation are entwined. I didn't tell you about researchers pursuing the development of a nuclear-powered artificial heart in the 1970s. I didn't tell you about the business of medical device innovation, how costly it is, how precarious it is. I didn't talk about the tremendous regulatory, reimbursement, and clinical uptake challenges for new devices that, in the case of the artificial heart, came very close to bearing this technology at various times in its history. But I will return to my earlier comment that artificial hearts are seductive devices. Indeed, they're life-sustaining technology, but there's risks and limitations. I argue that desirability, more than feasibility or practicality of artificial hearts, is what really drove the invention of this device. I argue that the allure and ambivalence of artificial hearts is what anchors the story of how and why this problematic technology continued to be developed. I argue that artificial hearts were and are situated as a technological solution to the problem of heart failure, and that an interpretive flexibility of success was key to its momentum and legitimacy. Please don't walk away and think that my historical account is very much a near-success historical account. I don't think this is a near-success device narrative that I want to promote. But I would like you to approach the history of artificial hearts as a case study that speaks to questions of values, expectations, meanings of success, and uncertainty in a high-technology medical world. It's a relevant case study when it comes to discussions surrounding the desirability and sustainability of expensive end-stage disease therapies in our healthcare system today. Maybe you have now been seduced by this technology, or better yet, seduced into reading my book and learning more about this controversial history. So February is Heart Health Month. May you all be heart healthy. Thank you.
Thank you very much for this timely talk for Valentine's Day. I want to turn it over to Dr. McKellar to answer any questions.
Certainly.
And we have the room for another hour, so feel free to ask questions and also to eat some cookies and take some coffee.
Yes, please.
Yes, thank you very much, Dr. McKellar, for a fascinating rendition of the history of artificial hearts. My question is, I'm curious in terms of who got these hearts over time. With the first experimental ones in people who really, you could, I mean, the stakes were actually relatively low in the sense of whether it was experimental, it was high risk, so whoever was up for it. So were these, lower expectations, lower socioeconomic patients, and then now we're at a point where the stakes are so high from the point of view of publicity and funding that they would only choose certain ones, or is it economic consideration? So what, I'm looking at from the patient side, not the recipient side.
Certainly. It's a great question. Who actually gets to be the first patient to receive these artificial hearts? Who goes first? I've given a talk on that before. Who goes first? And the 60s are quite a different time from the 1980s. So the 1960s, in terms of who goes first, is really at the decision of the surgeon, and in this case, surgeon inventor. So Dr. DeBakey, he has a very robust clinical practice. He's seeing the clinical need. He has access from his lab to these devices. He's going to make the decision of when he thinks he can transition a device from the lab to the bedside. Also, he'll have access to the patients, in which he'll be confident enough that he thinks that he may get a successful outcome. Many of these clinicians, when I've asked them to talk about, they felt that they are out of other options, that they feel that very much these people would probably have died anyways, but still it wasn't necessarily, they didn't think that it might not work, but they really did hope it would work. In the case of Dr. Kolff, great story here. Dr. Kolff is the inventor of the artificial kidney machine in Holland, and he went through 16 patients before he actually got any kind of success rate. So when he comes to the United States to try his artificial heart out, he thinks that only patients that have no other options, that are going to die anyways, we have nothing to risk, why don't we implant them in there? And he gets a lot of pushback, especially in the 1980s with the Jarvik heart, because what's happened in 1976, there's a new act that's gone through that actually controls FDA approval rates for new devices going into patients. So now Kolff's team has to go through all FDA approval to be able to have a subset of patients, if it becomes available, if we can't get them off the operating room table, all these to actually implant them in. And in the case of Barney Clark, he actually was a patient in the University of Utah Hospital in which his cardiologist had exhausted all the drug therapies. He said, listen, I know of this guy in the building next door. He's working on this artificial heart, something you might want to consider. And in fact, they go over and they tour the animal lab. He sees calves walking on treadmills with these artificial hearts. And him and his wife take a look at it, and this is in November of 1982. He thinks about it. He goes back up to Seattle and discusses it with his family, and then by December he's back down in Utah and decides, I will go for it. Interestingly enough, there's a guy in Florida that wants to be the first patient and petitions Kolff and his team to be that person, and he's turned down because he has too many other comorbidities and risks. So I think there was a choice by the inventors to make sure that we don't necessarily put it in a patient we know it will not succeed. So I think that it's a very difficult decision of when is the time is right and who is the right patient to try it out for the first time. But it's a great question. Thank you.
Do you think medicine is moving away from an art of healing to an art of fixing?
Interesting.
Can you repeat the question?
I will repeat the question. The question was a great question about, do you think the art of medicine is moving away from the art of healing to the art of fixing? So many people will argue that the artificial heart technology is an admission of failed prevention, and that healing is about the healthy body and maintaining health, diet, exercise, and equilibrium, as opposed to a therapeutic kind of outcome. So when the great debate happened in 1988, in which the NIH was seriously thinking about cutting funding of artificial heart research programs, the argument was just that. We need to divert all these funds back to prevention, back to healing, back to other areas that we can make a difference. That in fact these technological fixes are only just extending life in a marginal way, maybe not even with a near return to life that they want, quality of life issues, and that we need to get back to healing. We're not here just to thwart death. We're here for healing, extending quality of life. But I also think that it is a context in which the world of surgery is a very aggressive world. It's a very I can fix it world. And we talk about the technological momentum in medicine, that by the latter part of the 20th century is very strong, that I think the artificial heart technology is able to anchor itself in. Terry?
Curious, in all these cases you said they were given the artificial heart, waiting for a heart transplant. Barney did that first heart transplant. Was that the same kind of attitude? Did he get any kind of flack like this was alluring but ambivalent but alluring?
Great question. So Charlie's question was in terms of the heart transplants that were taking place in the 1960s when Christian Barnard in South Africa did the first heart transplant, if in fact in terms of using the devices as a bridge to transplant, in fact, if there was any pushback on that. Is that correct?
Right, because now it's become so normal that you're waiting for that as the ultimate fix.
Right.
But that was a fix.
So in the one chapter in my book, I argue that in the 1960s, there was two schools of thought about heart replacement. Is the best approach a human heart, or is the best approach a mechanical heart? And then xenotransplants is way off in terms of animals. That's way off in Neverland. It's not even thinking. So there's these two tracks, and no one knows which is going to be the better option. At that point, the mechanical heart is seen as not as a bridge transplant, because transplantation, as you know, in 1967, the first heart transplant occurred in December in South Africa, in which the rejection was so strong that there was a moratorium placed by the latter part of 1968, early 69. And it wasn't until the 1980s that immunosuppression drugs came out to make transplantation a viable option. So the balls were still in play. They didn't know which was going to be better. So Cooley's use of the Leota Cooley heart as a bridge to transplant arguably is not because he has an artificial heart research program. He is a heart surgeon. He's actually in the game of doing heart transplants. And he would like to do more heart transplants, but doesn't know how to get the donor hearts. So, and it's such a one-off, he doesn't implant any more artificial hearts. The artificial hearts for the 1970s and 80s is now trying to use, especially by the time of transplantation establishing themselves as the preferred treatment of the 1980s with the discovery of cyclosporine and better immunosuppression drugs, as another option to use artificial hearts. So in many ways it gives them another lifeline to say there's another clinical need for it, clinical use for it, and intended use for it. But very much in the 1960s it was a toss-up. So you have Norman Shumway over at Stanford saying, I wouldn't let my patients near a mechanical heart. This is awful. You're just sending them to death, and we'll have nothing to do with it. And then you've got Michael DeBakey, who's very much invested in mechanical heart, and says, there's no way we can have enough donor hearts to save all these people. And we haven't figured out the immune rejection. So it's very much two camps that emerge. And what's interesting is that I would argue the success of artificial hearts has been in that role as a bridge to transplant. And it's during its use as a bridge transplant device that new indications have emerged. Bridge to recovery, destination therapy for transplant-ineligible patients. And Dr. Lee can probably speak to this more than I can, but I think they found some cases of which people that are eligible for transplant are on the transplant waiting list, have a device put on them, and in fact their heart recovers and improves, and by the time a heart comes around, I'm good, thanks. Some cases, I think some cases in which their heart has recovered well enough with these devices, the device can even be explanted. So I think it's very much case-by-case experiences in which some bioethicists would argue the slippery slope of clinical indication, or you can even argue these indications are meaningless. Once you implant it, things will change. Do you want to add anything, Dr. Lee?
No, just to reiterate, for the public, getting a heart transplant does not mean that you have a brand new heart and now you have another 30, 40 years. It's another form of disease. You have to battle suppression, infection, and so on, and your life duration is not the same as with your own heart. It's actually much lower. So, so the debate is, if you have a artificial heart or an LVAD that is now refined, will you live longer with that, or will you live longer with a new heart? And the number of donors is fixed. Over the past 10 years, we've not seen a rise in the number of donors, so the number of transplants that we can do is relatively fixed. And so yet the number of patients needing a heart or a heart-assist device is going up. So there is this gap, and we have to find another solution. And that's another reason why the drive to improve technology, getting these mechanical hearts, has gone up of that need.
Thank you. Yes, please, the back.
I think the other thing, just to add to Dr. Lee's point, okay, is the idea that if you look at even artificial hearts now, since cardia, all the papers that are being published in New England, they no longer look at mortality as the primary outcome. They all look at how many patients made it to heart transplant as the primary outcome. And that's what they compare it to. So in the latest trial that came out, they said, we evaluated these many patients, and 79% of them who got the syncardia heart made it to transplant, compared to their matched cohorts who didn't get the syncardia heart, and only 40-odd percentage made it to heart transplant. So they're moving away from what you said, the indication being how long can these patients live, to how long can we make them go until they get a heart transplant.
That's a very good point. And in terms of, I think with Syncardia too, they've done a good job of expanding their patient population. I think they're implanting their total artificial heart in patients as young as teenagers now. They have also been very encouraged people to implant their devices in less sick people if I can say that, in terms of instead of stage 4, but maybe stage 3, a late stage 3. And I think that's helped their numbers as well. And I think, it's part of packaging too, and how successful this device is if your goal is to get you to transplant. But their numbers are still, I think it's something like 1,500, 1,800 that they've implanted since. So if we're talking about 26 million people with symptomatic heart failure in the world, we've implanted 1,500 total artificial hearts. A bit of a drop in the bucket. Yes?
Putting aside the R&D upfront cost, what is the cost per quality of life or cost per life year extended for these devices in today's dollars?
Well, that's interesting because that's very much used in the Canadian context in terms of cost-benefit kind of and the cost of the device. And so initially they said the cost of the device is very expensive, but it's going to come down as more people get implanted. We're not really sure. So the numbers that I've seen from 2012 numbers in American dollars is that to be implanted with an artificial heart device, both VADs or total artificial heart, is somewhere between 80 and 200,000. But that doesn't allow for rehospitalization or support afterwards. And that does meet the threshold in terms of the patient years cost-benefit analysis that they've had. It seems like a lot of money to me. Dr. Lee probably has better stats.
Well, so if you don't get the device, there's costs with re-hospital admissions and so on, but your life duration is shorter. So when you die, you don't use any health resources. So overall, the cost is lower, but that's because you're dead. And so if you prolong life, the cost will go up.
The cost will go up, yeah. Yes?
My question is about rhetoric. So we were talking about some of the criticisms coming from failures in the 80s. And at the beginning of the talk, you mentioned the idea of spare parts. And there's a great comic where the surgeons were taking like the parts out of the body like an engine. And I was wondering, throughout this process, period of study, were there criticisms about artificial hearts as like dehumanizing, like taking out organs and replacing with machines, or Frankenstein-like comparisons? Or is the allure of extending your life and having a new heart so strong that that's not really there?
It's a great question. So the question is about kind of the, for Niagara, this question is about the body being, a spare part ethos, the body being reduced to parts, and what that has to do with the understanding of what the heart is. And that's enough to encourage people. Well, first of all, they had to tackle this question that this particularly culturally loaded organ could be mechanically replicated, or at least its function, and that the state of the person would not be altered. So before that they had an artificial kidney machine, that was okay. An artificial heart, could you reduce the heart to a pump? And could you reduce it to parts of being steel and titanium and moving blood? And I think what happens with their ideas, and you can see some of the pictures I put on about the Tin Man, kind of the parts being moved back and forth, is that if you talk to the inner circle, the researchers, the surgeons, even the patients and the families, they kind of dismiss this idea that somehow their personhood is at jeopardy because this person will die without this object. I think when you step back at a rhetoric level and you look at Life magazine and you look at some of these images, I think the rhetoric about replaceable parts fits into the ethos of the 1950s, 60s, science, faith, and American know-how and engineering, abilities to be able to reproduce kind of the person. The whole cyborg kind of analogy doesn't really raise its head in the immediate medical circle, of course. I think it does become more of an issue in the 1970s and 80s when you see more of a criticism, an anti-science criticism that's emerging for all kinds of things. The rise of bioethics in the 1980s challenges it, but more on, as I mentioned with Swayze and Fox, kind of, they think it's hubris driven, this idea that we are that much about replaceable parts. And I think what's interesting, too, in talking to surgeons, is that this analogy of the heart as a pump was somewhat simplistic, and that they realized that once you start the complexity of replicating function of a pump, that perhaps the heart does more than just pump blood. So I think there's a respect there. There was a question on the back? Yes?
You referred to the long-standing battle between Michael DeBakey and Desmond Coolidge.
perhaps it should be, and this indeed was quite a battle for 40 years, I think you mentioned. But they did reconcile
They
at
did.
the end. In DeBakey's old age, he and Cooley did get together and settle their differences.
They did.
Rather seriously. I had the opportunity to visit the Texas Heart Institute on a couple of occasions and actually made rounds with Cooley on his post-surgical patients, not these patients.
No, no.
But he obviously was a remarkable surgeon.
If you met Dr. Cooley, he's tall, he's handsome, he's incredibly charming. Patients love him. He exudes confidence. I was at a conference when Dr. DeBakey came in, and so it's a full conference, a full lecture hall. I think there was, 500 people in it. And Dr. DeBakey comes in from the back, and it was like the air got sucked out of the room. He came in, and people just stopped talking. And he made his way to the front in his elevator shoes. He was a very short man. He was conscious about that. Made it to the front and talked, and then he left. But you're quite right. In 1997, the two men made up, and it was through their medical society. So there was a Denton-Cooley medical group, and the Denton-Cooley group gave Michael DeBakey an award, and then the Michael DeBakey more gave Dr. Cooley an award, and they came and shook hands. And so I've got a nice picture of Dr. DeBakey in his wheelchair, and then Dr. Cooley. And Dr. Cooley's actually written an autobiography. Did you know that? So it's an interesting read. So pick it up. It's an autobiography, and he has a different take on their feud and all the efforts he went to try to make up the feud. But there's huge names in the field, huge titans, and I think any cardiac surgeon would know the names, if not trained under them, because it's a very small world, and they've sent their students out throughout the United States and Canada. Yes?
With the technological advances that have happened or occurred from the 60s till now in the 21st century, do you know what the life expectancy or the number of years that people with LVAD are living?
Oh, the gentleman can answer that question just left. I'm an historian, but I'll get my crystal ball out. And in terms of what I've just seen by meeting some of these and talking to the doctors, in terms of they've had some patients live up to 15 years with LVADs. And hopefully you don't take this as an anti-technology talk or anti-artificial heart talk, because I think for some patients, this device has worked very well for them and provided meaningful extra time and improved. And many of these people who have been bedridden and had very poor quality of life hasn't returned them to life as a 25-year-old, because most of them are in their 50s, 60s, or 70s, but has returned them home and an improved life. Kathleen Shore is a great story. She was almost pronounced dead in the ICU. She returns for a year to her teenage kids, right? And she continues to go and get the groceries and run her kids around. Donor heart comes available in a year, and she's still living with her new heart. So, for some people, this is incredible technology, and the emphasis by the researchers and surgeons I talked to is the technology is only going to get better. So the HeartMate 2 that saved Cheney's life, that he says, they're working on a HeartMate 3 device that is smaller, that has less problems, less moving parts, and I didn't get into all the kind of engineering bits of it. They're even suggesting that they might even be catheter mounted in the future, less bits and pieces, that it'll become ubiquitous technology like you put a pacemaker in.
In some ways, all of us are living unnatural lives. Because if we relied on nature, our food would be different,
yes.
What we eat would be different, the way we live would be different. We are all technological fixes. So what are you
so nervous about?
We would be all dead if we had natural lives. Long time. I definitely. I'm 75, so I should be dead long.
But you don't have a VAD, so you're good. Yeah.
So I think that when we start talking about fixing and healing and so on, I think that debate is entirely artificial.
Because what is the technology? Is it the actual, it has to be a physical, or is the technology other technological systems, structures?
Clean water, clean air, proper food, nutrition, all of it, these technological fixes.
Absolutely. It's the larger technological system as opposed to a device that's in place. Sure. Question at the back?
Just from a technological perspective, I think the other thing that's starting to come out, and I don't know if you looked into that, is stem cells as well now. With a heart failure, wherever it's ischemic. Have you found anything in terms of sort of in the past or moving forward, how the public sees stem cells? Because I think we're more readily accepting of actually mechanical hearts than we are of stem cell therapy.
There's a French company. The question had to do with stem cell research and kind of what role will that play in mechanical hearts, or at least in patients' perceptions of which is the better option to go with. So in terms of in terms of artificial heart research, there is a French company that's actually designing a kind of hybrid device. Are we thinking of that one? That is the stem cell and with the device. Would that make it more palatable to you to say this is really isn't a full device, foreign device, that it's somehow been grown from your cells? Is there a sense of rejection that you feel, a foreign body in your body? I don't know. They've had some encouraging results, but it's not clinically approved for use. And of course, the other route that, in terms of replacement technology for the end-stage heart failure patient, if heart transplant is the gold standard, but you're not one of the 2,200 people in the U.S. or the 250 people in Canada to get a donor heart, what are your other options? There's xenotransplantation, which gets dogged out all the time, that somehow we can grow animal parts or implant animal parts, and that seems to be still fantastical and off in the wind. And the mechanical part seems to be creating more ground there. I think it's more people are open to it. Here in Canada, we implant both. In Ontario, it will happen at London, the University Hospital, or Toronto, or Ottawa. Heart Institute.